So first we are looking at the general characteristics of mid-latitude cyclones. So mid-latitude cyclones, also known as temperate or extratropical cyclones, are large weather systems that occur between 30 degrees and 60 degrees latitude in both hemispheres. Now remember, if they do ask you a question, but instead of saying mid-latitude cyclones, they say temperate cyclones, just know that that is the exact same thing, right? Temperate cyclones is just another name for mid-latitude cyclones. Now mid-latitude cyclones move from west to east, right? That is known as eastwards or in an easterly direction. So if you are asked in which direction will mid-latitude cyclones move, then your answer should be from west to east. Now at this point we'll go through two very important pieces of information, right? They typically cover a large area, a diameter of about 1,000 kilometers, and bring varied weather conditions including cloud cover, strong winds, and precipitation. So they're talking about the diameter, which will be 1,000 kilometers, and they are talking about the weather conditions that are associated with mid-latitude cyclones. So mid-latitude cyclones affect South Africa mainly in winter, and it generally lasts between 4 to 14 days. Now let's look at the conditions necessary for formation. So our first condition would be warm subtropical air from 30 degrees north and south meets with cold polar air from 90 degrees north and south at the polar front, which is located at 60 degrees north and south. So let's look at our diagram, as that will help us to understand this point a little bit better. So warm air that is found here, 30 degrees north, will meet with cold air, right, cold polar air, which will come from your 90 degrees north, right? And the warm and cold air will meet here at the polar front, which is located at 60 degrees north. Now this will happen in both hemispheres, so this can occur here in the northern hemisphere or in the southern hemisphere. So let's look at it in the southern hemisphere, right? Warm subtropical air from 30 degrees south will meet with cold polar air from 90 degrees south, and they will both meet at 60 degrees south, which is also known as the polar front. Now both air masses move parallel to each other in opposite directions, as we can see in the diagram, right? They are moving parallel to each other and in opposite directions. So in the northern hemisphere, your cold polar air will move south and the warm subtropical air will move north. Now there is frictional drag between the air masses and it causes them to interact with each other. Now you may be wondering, why will frictional drag occur? Right? What causes it to occur? Right? There are three reasons why it will occur. And now the first reason will be because of a difference in the speed of both air masses. Remember, cold air will be a lot more dense, therefore it will move a lot quicker than your warm air. The second reason why it will occur is because of the uneven surface that they move on. And the third reason would be because of differences in temperature between the surface of land and sea. Now we will look at the stages in the formation of mid-latitude cyclones. So we start off with our first stage, which is the initial stage. Now in this stage, warm, moist subtropical air meets cold, drier air along a stationary polar front. Remember, a polar front can also be called a stationary front. So just remember that. So in the diagram, we can see the warm subtropical air will be represented by a red arrow, right? And the cold polar air will be represented by a blue arrow. Now we can see that these two air masses will move parallel to each other in opposite directions, right? Obviously at the polar front, which is located at 60 degrees south or 60 degrees north. The air masses move parallel to each other in opposite directions on both sides of the front, right? This is exactly what I just said now when we were looking at the diagram. The Coriolis force will deflect both the air masses towards the left in the southern hemisphere, which is why they move parallel to each other in opposite directions. Now we look at our second stage, which is known as the wave stage. As we can see in the diagram, there is a cold front and a warm front, and you can obviously see it is in the shape of a wave. Now how do we know which is the warm front and which is the cold front? Because in your exam it will not be color coded. The warm front will obviously have semicircles along the line, and a cold front will have triangles along the line, right? That's the most simple way that you could remember that. A disturbance along a stationary front creates a wave. Now warm air begins to be uplifted by the cold air, because remember, warm air is less dense than your cold air, and your cold air will move faster than your warm air. A low pressure sensor begins to develop at the point where the cold and warm air masses meet. Now this is the point at which they meet, right? And at that point, a low pressure sensor will begin to develop. Remember, in a cyclone, the lowest pressure will be found in the center of the cell. We now look at the third stage, which is the mature stage. Now if we look at the stage, right, in the diagram, you can see it forms a V shape. Can you see that? And we can also see two pressure readings, right? In the center, it's 1002 millibars. And then as you go outwards from there, the pressure will then increase and move on to 1004 millibars. So the cyclone intensifies as the cold and warm fronts become more distinct. Can you see they're a lot more distinct in this stage than the previous stage? So the wave deepens into a fully formed V shape, right? As I've said, you can see it will represent a V shape. The warm air rises over the cold air and the cyclone becomes more organized, forming an open wave shape. Now this is a very important point, right? Now we are discussing the weather associated with this stage. So this stage is associated with widespread cloud cover, precipitation, and strong winds. Now weather patterns may vary on either side of the fronts. Remember, because one is a warm front and one is a cold front. They both will bring different weather patterns. We now get on to the fourth stage, which is known as the occlusion stage. Now we are coming towards the end of the life of a mid-latitude cyclone, right? And in this diagram, you can see now there is an occluded front because the cold front has caught up to the warm front, right? And again, we can see that the lowest pressure will be found in the center, and this pressure is 998 millibars. Remember, pressure is recorded in millibars. So the cold front catches up to the warm front, and that is because your cold front has cold air. Cold air is dense, so it will move a lot faster. And this will lift the warm air entirely off the surface. This process creates an occluded front, where the warm air is no longer in contact with the ground and the system begins to weaken. Can you see there's an occluded front, right? There are triangles and semicircles. And heavy precipitation can occur at this stage as warm, moist air is forced to rise rapidly. We now get to the last stage, which is the dissipation stage. Now we are right at the end of the life of a mid-latitude cyclone. So as the energy source, which is the temperature contrast, weakens, the warm air is fully lifted and the cyclone loses strength. The system gradually dissipates and the weather conditions improve with fewer clouds and less precipitation. So the impact and the precautionary and management strategies very often come out as essay questions. Now each essay question will come out for about 8 marks, and that is a lot of marks, right? If you can score total in that section, then you are starting off on a very strong note, right? So let's look at the positive impacts of mid-latitude cyclones. Now these systems bring rain and snow to many regions, providing essential water for ecosystems, agriculture, and human use. In areas prone to dry conditions, the moisture from mid-latitude cyclones can be critical for replenishing soil and water reserves. So just think about this for a second. If you are living in an area that is very dry, right, your water reserves are low, the rain that comes from the mid-latitude cyclones will be extremely beneficial, not only for you, but for farmers, right? This will help them with their livestock, it will help them with their agriculture and plants. So this water that is brought in the form of rain from a mid-latitude cyclone, it will bring much needed relief to everyone in that area. The precipitation from mid-latitude cyclones helps to nourish soils and support plant growth, which is beneficial for agriculture. The rain carries nutrients into the soil, promoting healthy crops and vegetation. Right, that's just another point supporting the benefit of the rain that is brought with the mid-latitude cyclone. The strong winds and precipitation associated with mid-latitude cyclones can help clear pollutants from the atmosphere, improving air quality. This can be particularly beneficial in urban or industrial areas where air pollution is a concern. So let's say you live near a factory and that factory is constantly pumping out toxic gases into the atmosphere. The strong winds that you will get from a mid-latitude cyclone will help to blow those toxins away, and you will then have clean, fresh air to breathe. In colder regions, mid-latitude cyclones contribute to snowfall, which leads to snowpack accumulation. This snow melts during warmer months, providing a critical water source for rivers and communities downstream. Remember, once snow melts, it will become water, and that water will then run off into rivers and also fill up dams. So that's a huge positive impact, right? We now look at the negative impact, right? If you look at the diagram on the left, we can see there's flooding, there's hazardous ocean conditions, there's soil erosion, as well as damage to your cattle because of snow. The heavy rainfall associated with mid-latitude cyclones can lead to flash flooding or river floods, particularly in low-lying or poorly drained areas. This can cause significant damage to homes, roads, and farmland, displacing people and disrupting communities. Remember, floods can damage your home, can damage all your furniture. People can even drown because of this flooding. Prolonged storms, flooding, and extreme cold associated with mid-latitude cyclones can cause significant damage to crops and livestock. Heavy rains may lead to waterlogging, and snow or ice can harm crops. Livestock may also be affected by severe weather conditions and freezing temperatures. Remember, certain animals are not used to these cold temperatures, and once they are exposed to this, they can die, and that will cause a massive loss to farmers and the community. Soil erosion occurs from the heavy rains and will damage the environment. Mid-latitude cyclones create rough seas characterized by large waves, strong winds, and dangerous currents. These conditions can be hazardous for ships and maritime operations, leading to the capsizing of smaller vessels and delays of ships, affecting global shipping and supply chains. Increased risk of accidents, particularly in fishing and transport industries. These storms can also endanger the lives of sailors and fishermen, requiring them to avoid affected areas or seek shelter. Now, a lot of people rely on fishing, right, to bring in an income for them and their families. And if there are hazardous conditions out at sea, they won't be able to go there because obviously their boat can capsize and they will lose their lives. So the hazardous conditions out at sea will be a very negative impact. Now we will look at the precautionary and management strategies, right? Obviously, these can also be asked in an essay form, and you would have to give 8 strategies and obviously explain each strategy. So today I'm going to be giving you 9, as that will definitely give you more than enough, right? And they all are simple, so they are easy to remember. So our first strategy is houses should not be built in low-lying areas as they will be affected by floods. Can you see? It's simple, easy to remember. The second strategy, an efficient drainage system should be implemented in urban areas as this will reduce the risks of flooding. Strategy 3. Sheep and other livestock must be placed in a kraal or shed in order to keep them safe. Number 4. Farmers should keep sufficient feed for the livestock in order to avoid livestock losses. Number 5. Always monitor weather patterns and conditions before going on any outdoor adventures. Now, outdoor adventures, they're not only referring to hiking, they're also referring to activities that can be as simple as going to the store. Right? That can be dangerous if there's a mid-latitude cyclone coming. Strategy 6. Remain indoors during hazardous conditions. So if you see there are large grey clouds, if you see there's heavy winds, then please remain indoors. Number 7. Stock up on all essentials such as batteries, food, and medication. Number 8. Building and maintaining sea walls, levees, and storm surge barriers in vulnerable coastal areas can help protect against flooding and storm surges. Now, number 9. Identifying and zoning high-risk flood areas can prevent construction in vulnerable regions and reduce potential damage. Properties in flood zones may require elevated foundations or other flood-proofing measures. So first, we're going to be looking at the general characteristics of tropical cyclones. So tropical cyclones form over warm ocean waters, typically between 5 degrees and 20 degrees latitude in both hemispheres. They require sea surface temperatures of at least 27 degrees Celsius to develop. And I'll explain to you exactly why that is so once we get to the conditions necessary for formation. High humidity in the atmosphere is crucial for their formation, particularly in the lower and middle troposphere. Tropical cyclones typically last from a few days to several weeks depending on environmental conditions. Now that's very important because that can be asked. They will ask, how long do tropical cyclones typically last for? They move from east to west and they are steered by the easterlies. So if they ask you what direction will tropical cyclones move in, you will say they will move from east to west, or you can say they will move in a westerly direction. They average between 300 and 500 kilometers in diameter, with the eye being plus minus 30 kilometers in diameter. Now again, that's also very important because that will indicate the size of the entire cyclone and the eye. So our first condition that is necessary for formation will be sea surface temperatures must be at least 26.5 degrees Celsius or higher, which provides the energy needed for the cyclone to form and intensify. The warm ocean water evaporates, adding moisture to the air, which fuels the storm. Now, moisture is very important for the storm, right? That is why you have to have an ocean temperature of at least 26.5 degrees Celsius. The next condition will be the atmosphere must be unstable, meaning warm, moist air near the surface rises and cools as it moves upwards. This rising air helps generate the towering thunderstorms needed to sustain a cyclone. Tropical cyclones form between 5 degrees and 25 degrees latitude in both hemispheres because the Coriolis effect. Now, the Coriolis effect is the deflection of moving objects caused by the Earth's rotation, right? So this is necessary to create the cyclone spin. Near the equator, the Coriolis effect is too weak for cyclones to develop. Therefore, it has to develop between 5 degrees and 25 degrees latitude in both hemispheres, right? Number 4, there must be high humidity, which is moisture in the air, in the mid to lower levels of the troposphere. This is the layer of the atmosphere that is closest to the Earth's surface. This moist air is important for the formation of clouds and thunderstorms within the cyclone. Now we get to the stages, right? And our first stage is known as the initial stage. So, pressure is above 1000 millibars at the center in this stage. So let's look at the diagram quickly, right? We can see that this is a low pressure system. How do we know? We can see that the lowest pressure will be found in the center, right? And that will be above 1000 millibars. Its exact number is 1004 millibars. And we can see as you go outwards, the pressure will increase. Now these arrows, these orange arrows, will represent the flow of air, right? And whenever you see arrows flowing into a low pressure cell, that is known as convergence, right? Convergence is the movement of air into a low pressure cell. So let's look at our second point. There is a big distance between isobars. Can you see that's a very large distance between the isobars? Now the distance between your isobars is basically your pressure gradient. So if there's a larger distance, there's a more gentle gradient, right? Same thing with map work. When warm air converges towards the center of the storm, an eye forms. So light rain occurs and gale force winds occur up to 50 kilometers from the eye. We now look at the second stage, which is known as the immature stage. So in this stage, the pressure at the center will drop below 1000 millibars. Let's look at our diagram here. Now we can see that in the center, there's an eye that has formed. We can see that the pressure at the center is well below 1000 millibars, it is actually 980 millibars. Remember, in a cyclone, which is a low pressure cell, the lowest pressure will always be found in the center. And we can see again, these arrows will represent the movement of air as it converges into the low pressure cell. So as the air continues to converge into the center, the eye intensifies. As you can see, that is the eye right there. Now in this stage, hurricane strength winds will occur. The diameter is 100 kilometers, right? That's also very important to know. And in this stage, which is the immature stage, cumulonimbus clouds can be found around the eye. Now we get to the third stage, which is known as the mature stage. Now we can see a lot is happening in this diagram. So let's look at the point and let's get back to the diagram. So the pressure at the center is well below 1000 millibars and it will remain at that reading. Can you see it's at 982 millibars? Now in the center you can see the eye is a lot more defined. We can see there is a very small distance between the isobars and we can see the presence of a dangerous quadrant. A steep pressure gradient is indicated by isobars that are located close to each other. Can you see how close they are? So the closer they are, the steeper the pressure gradient. So the diameter is 300 kilometers to 500 kilometers. Right now, the tropical cyclone is in its peak at this stage, in the mature stage. So you may be wondering, what is the dangerous quadrant? The dangerous quadrant will experience the most severe conditions. So within the dangerous quadrant, you will have the most severe weather conditions. So you can have torrential rain, you can have heavy winds, you can have hail, there's thunderstorms. All of that will be found in its most severe form in the dangerous quadrant. Massive cumulonimbus clouds form around the eye. And again, in the mature stage, the wind speed is more than 120 kilometers an hour. Now we get to the last stage, which is known as the dissipating stage. Now this is the end of the tropical cyclone's life. So the tropical cyclone will begin to dissipate once the pressure rises above 1000 millibars. Now there are many reasons why a cyclone will dissipate, and today we're going to be looking at three causes, right? There's three causes of dissipation. So the first cause of dissipation will be when a tropical cyclone moves over land, it loses its main energy source, which is warm ocean water, right? Friction from the land also disrupts the airflow, weakening the storm. The second cause of dissipation is moving over colder ocean waters, because remember, you have to have a minimum of 26.5 degrees. So once the ocean waters drop to below 26.5 degrees Celsius, it reduces the energy available to the storm, and this will cause it to weaken. Now, high vertical wind shear can distort the cyclone structure. This will pull apart its core and inhibit further development. Now I want to go through the weather that is associated with tropical cyclones. So as a cyclone will approach, there will be a wind speed of more than 120 kilometers an hour, right? There will be heavy rain, there will be hail, lightning, and thunder, right? Remember, this is as the cyclone will approach. We then look at the weather that is found in the eye, right, in the center. This will be calm conditions, there will be no rain, and the lowest pressure will be found in the center. So why is that? This is because the upward spiraling movement of air will create an artificial wall around the center. Now that wall will prevent any surface air from rising and cooling, and because of that there will be no condensation that will occur, and if there's no condensation occurring, then there will be no clouds or rain produced, right? And as the cyclone moves away, the weather conditions will be the same as when the cyclone is approaching. So basically they will have very high wind speeds, there will be heavy rain, hail, lightning, and thunder. So I hope this diagram makes it a lot easier for you to understand. So now we're looking at the effects of tropical cyclones. Now this can come out in the form of an essay. What you can do is you can take a screenshot of the screen, obviously, as we're going through the effects. And when you're writing it down in a notebook or on an exam pad, write it down in the form of an essay and memorize that essay. So when you go into writing your exam paper, you know exactly, okay, cool, this is how I answer this essay question. And like that, you can ensure that you get total in that section. So the first effect will be strong winds, right? Now, wind speeds in a tropical cyclone can exceed 250 kilometers an hour in the most powerful storms. These winds can cause damage to buildings, homes, and infrastructure like power lines, bridges, and roads. These winds can also cause the uprooting of trees and the destruction of forests. There will be widespread power outages, and flying debris can be life-threatening. As you can see in the diagram, there are a lot of uprooted trees, and these trees can fall on homes. And if you are sitting in a room and the roof caves in, then obviously that's going to be life-threatening. The next effect will be heavy rainfall. Now, tropical cyclones bring torrential rains that can lead to flash floods in urban and rural areas. There will be overflowing of rivers and lakes, causing large-scale inundation. There will also be waterlogging of crops and agricultural fields, which will lead to crop destruction. Next, we can see storm surge. So this is the abnormal rise in sea level caused by strong winds pushing seaward water towards the coast. Storm surges can flood coastal areas, leading to severe damage to homes and infrastructure. It can erode coastlines and destroy natural barriers like dunes and mangroves. It can also contaminate freshwater supplies with salt water. So what are the economic impacts of tropical cyclones? Not many people speak about this, right? So rebuilding after a cyclone is extremely costly. Governments, businesses, and individuals may struggle with long-term financial recovery. Damage to critical infrastructure such as roads, power lines, hospitals, and schools can take months or even years to repair. The economic cost to agriculture and industry often runs into billions of dollars, or in our case, rands. And the loss of tourism in tropical regions can severely affect local economies. The next effect will be environmental degradation. Coastal ecosystems such as coral reefs, mangroves, and wetlands can be damaged or destroyed by cyclones. This can lead to long-term changes in marine and coastal biodiversity. Soil erosion and salinization of agricultural lands can affect farming and food production for years. Now, what are some management strategies, right? How can you manage the effects of tropical cyclones? Firstly, you can implement early warning systems. So these are weather forecasting and monitoring, right? Meteorological agencies can use satellite images, weather radars, and computer models to track and predict cyclones. Early warnings can help authorities and communities prepare for the storm's arrival. They can also issue cyclone alerts. So public alerts and notifications should be issued well in advance, characterizing the cyclone's potential severity. Example, watch, warning, or emergency. Flood defenses and storm surge barriers, right? So construction of levees, sea walls, and storm surge barriers can protect coastal areas from flooding caused by storm surges. Another very important management strategy is supplies, right? So people should buy and stock up on essentials such as canned foods and water, because obviously during a tropical cyclone, you're not able to leave your home. So you're going to need canned food and water in your home to last a long time. People should also purchase medical kits. The next strategy is cattle safety. Remember, cattle should be either moved to higher ground or kept in safe structures such as kraals or sheds. If a farmer is going to leave his cattle out, then they all are going to get killed, and it's going to be a major loss for him and the community. There needs to be pre-planned evacuation routes. Authorities should establish and communicate evacuation routes and shelters in cyclone-prone areas. Communities should also be trained on evacuation procedures with drills conducted regularly.